My name is Bill Bowen and I'm a project management instructor here in Ottawa, Canada. In this video, I'm going to introduce some of the major quality management related topics. We'll begin the video by first reviewing some of the terminology that we'll need to know, then move on to examining the various quality knowledge areas, tools, and techniques. So let's get started. As stated in the PMBOK guide, quality management seeks to minimize unwanted variation in our project's processes and verifies that our results meets our requirement. There are three main processes associated with quality. These are quality management, quality assurance, and quality control. Before we look at each of these processes, let's first examine some quality-related terminology. For projects, the term requirement refers to what needs to be done on the project. A requirement specifies a condition or capability that the project must create, develop, provide, or otherwise demonstrate for it to be successful. Quality control is focused on understanding if the project's requirements were successfully achieved or not. As part of quality control, a quality manager ensures that the project's requirements can be quantifiably and measurably demonstrated. While quality control is focused on what a project has to do, quality assurance is focused on ensuring that the work on the project is done correctly. Work on a project should follow industry best practices, which is done by following appropriate policies, processes, procedures, and instructions. Policies specify the principles or rules behind project governance. Processes define logical workflows for the projects. Process defines a logical workflow for the project. Procedures define a set of implementable steps that describe the details of each process. And then finally, instructions specify how the work for each step in the process needs to be done. Collectively, policies, processes, procedures, and instructions describe the industry best practices and define how work on a project should be done. Let's see how that works. This image shows the relationship between an organization's policies, processes, procedures, and instructions. What it shows is that an organization makes policies. Each policy can have one or more associated processes. Each process can have one or more associated procedure. And each procedure can be supported by specific instructions. An understanding of this relationship will be needed when it comes to quality assurance. Let's see an example of each of these terms. This image would be an example of a process that has been created in support of an organization's policy on change management. The organization might have a change management policy that states all changes to project scope must follow a standard controlled process that ensures appropriate analysis, planning, and execution of all change requests. In this case, the process is shown as a flowchart, which shows the high-level steps involved in the process. As you can see, a process is very useful in understanding the overall workflow that is associated with a policy. However, on its own, a process does not provide enough detail to actually complete a change request for the project. For this, we'll need additional details that can be found in the procedure. In this form, we can see part of the actual project change management procedure. This form contains the step-by-step actions that make up the procedure. Notice that each step in the procedure is supported with additional detailed instructions that guide the reader in determining what information is required at each step. Collectively, policies, processes, procedures, and instructions go together to describe industry best practices for how things should be done on a project. Collectively, processes, procedures, and instructions are sometimes referred to as project standards. Standards are a collection of best practices that have either been created externally to the organization by an agency such as the International Standards Organization, or have been developed internally within an organization. One of the jobs of the quality manager is to make sure that all work on the project is done according to its associated standard, thus ensuring that the work is done correctly. Let's look at some more terminology. We consider something to be a quality product if its inherent characteristics allow it to fulfill its requirements. We use the term grade to define a product's inherent set of characteristics. A product with a different set of inherent characteristics can still be capable of fulfilling the same set of requirements, but it would be considered a product of a different grade. We use terms like upgrade and downgrade to qualitatively assess products with different inherent sets of characteristics. The key point is that both a high-grade and low-grade products can have the same fitness for use and fulfill the same requirements, while a low-quality product are products that would be unacceptable for use regardless of what grade they are. Let's see how all these different terms relate to each other. We'll use the simple outlet switch that we find in all of our homes to demonstrate each of these terms. The outlet switch is what allows us to access power for our various devices, but the outlets come in many different forms. Some are fancier than others, and thus might be considered to be of a higher grade because they have a different set of characteristics, even though they fulfill the same requirement. Furthermore, if an outlet switch does not work or is of poor quality, then it is unacceptable, regardless of what grade it is. On a home construction project, the project requirements would specify that each room in the home needs to have electrical outlets. The grade of the outlet covers might be specified as being low-grade plastic cover outlets. The technical requirements for the project would be used to specify where the outlets need to be located within each room. To add to this, the project would specify applicable standards, such as the electrical code, that describe how the work is to be done. Don't forget, standards describe the processes, procedures, and instructions for how work is to be performed. This illustration demonstrates how requirements, grade, and standard go together to specify what needs to be done and how it is to be done on a project. Another concept that is covered in the PMBOK is that of measurement precision and accuracy. These two terms are often mistakenly thought to mean the same thing, but they have different meanings. Precision refers to the consistency of the results of the measurements. For those of you with a statistical background, it means that the standard deviation is quite small among the measurements, while the term accuracy refers to the correctness of the results. Let's see how these two terms relate to each other. High accuracy and high precision measurements mean that the measurements consistently reflect the true value. Low accuracy and low precision measurements means that your results are very consistent, but they do not reflect the true value. High accuracy and low precision means that the average of your total measurements might reflect the true value, but any one measurement may not. And of course, low accuracy and low precision measurements are of minimal, if any, value. Essentially, they're bad data. Having covered the basic quality terminology that we will need, we can now look at the concepts behind quality management. Dictionary definitions are often inadequate in providing a full understanding of the concepts of professional quality management on projects. Even in discussions among individual quality management experts, you will find different definitions for how quality management is used and what it means. The PMBOK guide specifies that quality means minimizing variation and bringing consistency to producing outcomes. But where does this definition come from? The PMBOK guide draws much of its quality-related industry best practices from the International Standards Organization, or ISO. ISO is used within a manufacturing industry to ensure that an organization has the processes and procedures in place to produce very consistent products. It is why when we buy an iPhone, a car, or some other product, our expectation is that it will work perfectly. When you think about it, it's quite amazing that each product we purchase rarely, if ever, has any defects in it. A true testament to how good quality management can produce consistent products. However, within a project management environment, we are concerned about more than consistency in what we produce. Since we often produce unique outputs, consistency is hard to determine. A better definition of what we want our results to be is to be useful, beneficial, and of course, satisfy the original requirements. As such, within our project management plan, we have a special section dedicated to quality management planning. In our quality management plan, we specify what standards the project must adhere to and how adherence will be determined. We also specify how we will determine if the project's requirements have been achieved or not. To achieve this, the quality knowledge area is divided up into three main processes. Quality management identifies the quality requirements and standards for the project and determines how compliance will be demonstrated for the project. Quality assurance relates to defining and enforcing the project's processes and procedures. In ongoing operations, quality assurance also includes quality improvement, which focuses on improving or enhancing these processes and procedures. Quality control is all about testing. It is the evaluating of the project's results, ensuring that they fulfill customer expectations and are free of defects. Let's take a look at each of these knowledge areas. Quality control is reactive in nature. It is all about the testing and detecting to see if defects exist in the project's outputs. It involves monitoring and recording results of the quality activities that test or assess the performance of the product. Its goal is to detect gaps, deficiencies, and non-conformancies to requirements and specifications. It also strives to identify the root causes of poor quality. Quality assurance, on the other hand, is proactive in nature. It is all about understanding and improving the project's processes to prevent future defects. It is the process of auditing both the quality requirements and the results from the quality control measurements to ensure that appropriate quality standards are being used on the project. Quality assurance tries to ensure that the right processes and procedures are in place so that the work is done right the first time. So to recap, quality assurance is focused on defining and monitoring the processes and procedures that a project uses in producing its outputs, while quality control is focused on ensuring that the results or outputs that are produced are acceptable and without defects. Now let's move on to quality management. Quality management is done during the planning phase of the project and involves setting up the quality framework for the project. As part of this process, the standards and operating procedures that the project will use will be identified, and the methods of determining if requirements have been fulfilled will be established. Let's look at how this is done. Keep in mind that project activities are happening all the time during the execution phase of the project. To keep ahead of these activities, quality planning must be done in advance. The project's quality management plan needs to ensure that the right processes are in place so that the work is done correctly, and that the right verification is happening so that the end results can be shown to be acceptable. To be able to develop a proper quality framework for the project, you first need to be able to understand the project's scope and its workflow so that the correct quality standards can be identified and the right quality-related data can be collected. As project managers, we already have some useful tools that will help us. We can examine the project's work by using tools such as our work breakdown structures, our WBS dictionaries, Gantt charts, and network diagrams. This information provides useful insights into what standards will be needed on our project and how the scope can be verified. Our project WBS and scheduling tools are great for showing the managerial level of a project. That's the first 3 levels of the WBS, but there exists a considerable amount of additional information that is not captured using these managerial tools. These lower levels of the WBS detail are usually recorded within checklists, procedural documents, or modeling tools such as a flowchart. The information contained in these lower WBS levels is sometimes very important in understanding how quality management needs to be conducted on a project. Let's look at how flowcharts can be used to illustrate these lower levels of detail. A flowchart diagram uses symbols to model a process so that it can either be taught to the workers or examined to determine its strengths and weaknesses. The symbols shown on the screen are the basic symbols used with a flowchart. Some common uses for a flowchart include illustrating the lower levels of a WBS, showing the project's processes or its workflow, modeling task predecessors, documenting a process, or even modeling computer algorithms. Let's see an example of how this would be used. This example of a flowchart uses the basic flowchart symbols to model a simple project order fulfillment and shipping process. You can see how the activities, decision points, and documentation requirements have all been represented. This level of detail is often needed to be able to identify applicable quality standards for the various project tasks. There are many professional flowchart creating applications available, but even common office productivity tools such as PowerPoint support the creation of flowchart by including all the flowchart symbols. Once you understand the workflow and project outputs, you need a way to measure them. These measurements are often referred to as the project metrics. A metric is used to determine how success will be measured on the project. Metrics are simply a project attribute or characteristic combined with a way to measure that attribute or characteristic. Metrics are selected by the project manager and the quality manager and should represent meaningful project attributes and their measurements. For example, you might decide that a metric for assessing a project supplier is that their cost estimates for the project supplies should be within 10% of the actual cost. If the cost turned out to be more than that, then they are not a good supplier. Project metrics can be recorded in your quality plan using a table such as this. While project metrics are very useful, they need to be realistic. Benchmarking offers a way to compare what is happening on your project to what is normal within the industry. For example, before deciding that all supply costs should be within 10% of the original estimate, you should see if this is realistic and normal within the industry. You can examine industry trends to see what is occurring on other projects, and in doing so, you can determine if your expectations for this project are reasonable or not. Having identified quality standards and metrics, you need some way to make sure that the overall system is working. For this, we use quality audits. Quality audit examines the processes and procedures that are used to create the project deliverables, not the deliverables themselves. Quality audits are structured independent reviews that are designed to determine whether project activities have complied with the organizational and project policies, processes, and procedures. For example, change management is a large part of all projects. You may wish to conduct a quality audit to confirm that the change management process was followed throughout the project. This audit might include ensuring that all changes to the project scope were properly identified, analyzed, and assessed. All change requests followed a structured approval process. The project's resources and schedules were adjusted to accommodate approved changes. Only changes that had been formally approved were implemented. That was an introduction to the idea of quality management. Now let's look at quality assurance. Quality assurance uses the metrics and quality standards that are defined as part of quality management, along with the verification data that is collected in quality control to assess and improve the project's processes and procedures. The PMBOK guide provides a number of methods to examine a project's processes and procedures. Within this video, I will not examine each one, but instead show how some of them can be used in support of process analysis. Let's look at how a few of these quality assurance tools can help track down a problem that a project is having. The project is having the problem that some of the project deliverables are not getting to the customer. In this scenario, the problem seems to originate in the following areas: the actual transportation of the deliverables to the customer, the skill and training of the shipping department workers, the shipping department's communication protocols, and the actual process of packing up and labeling each deliverable. We can use a tool called a histogram, which is essentially a bar chart. This tool is used to show the number of incidences that have been encountered in each of the areas or categories. Histograms show how data is dispersed between various categories. We can also represent the information as a Pareto diagram. Pareto diagrams are a variation of the histogram, but they show the data in the frequency of occurrence. They also include a summation line that shows the cumulative effect of the various categories. During process analysis, Pareto diagrams are another way to visually represent the gathered data. Histograms and Pareto charts help us understand the categories of incidences, but we need to understand why they happen. To aid in conducting our analysis, we again use the cause and effect diagrams that we encountered in risk management. This root cause analysis tool can help us understand why a process is not working. In our scenario, we need to understand why our deliverables are not successfully arriving with our customers. We can set up our cause and effect diagram and explore in depth each potential problem area. Let's see what this type of diagram would look like. This image shows how we might set up a cause and effect diagram to identify potential root causes of our delivery problems. By identifying the potential root causes of our problem, we can then focus our efforts on finding which of the potential root causes are actually leading to our problems. And by doing this, we can hopefully update our process to eliminate those root causes. Another tool that might help in our analysis efforts is the control chart. Control charts are used frequently in manufacturing to track repetitive activities to determine if their processes are stable and resulting in predictable performance. For example, you could track how many products a particular machine is capable of producing each week and see if, over time, the number of products it produces increases or decreases. In this case, I have used control charts in a little different and creative way. I have showed how a control chart can be used to graph the number of overtime hours that our shipping department records. The graph shows that on week 7 there was a jump in the overtime billing. This might provide insight into the root cause of why our deliverables are not making it to the customer. Let's follow our analysis further by introducing statistical sampling. Statistical sampling is the practice of validating a large population by testing only a portion of that population. It is useful when it would take too long to test everything. For example, on a construction project, the quality manager might select 10 engineering drawings at random from a list of 75 drawings to see if the 10 selected drawings meet the quality requirements of the project. If they do, then it can be assumed that the rest of the untested drawings would also meet the requirements. In our delivery problem scenario, we may sample 10 deliveries that were sent during high-stress overtime periods and 10 deliveries that were sent during regular working hours. If the sample deliveries that we examine show that there's a correlation between the workers' hours and deliveries not making it to their destination, we may have a root cause of our problem. We can use scatter point charts to present the results of our statistical sampling. The graph on the left shows that as the number of overtime hours increases, so does the number of incorrect deliveries. The graph on the right shows no correlation between overtime hours and incorrect deliveries. Scatter point charts are useful ways of visually showing the strength of the correlation between variables. Note, scatter point charts only show correlation between variables. They do not prove causation. That was an introduction to how some of the quality assurance tools can be used in process analysis. Now let's look at some quality control. Quality control is a reactionary approach that is used to identify and detect defects and poor product quality. It is used after the project outputs are produced to validate that project deliverables and work meet the specified project requirement. When it comes to testing, there are only a few different ways that things can be tested, either through direct measurements, visual inspection and observation, or indirectly through analysis. On projects, testing is often done through inspections. An inspection is a direct check to see if the work done or the products produced meet the specified requirements for the project. One of the main tools used in inspections is the checklist. There are three key elements to a checklist. It needs to contain a list of all the project requirements that need to be met. It has to have a method of testing or assessing each of the requirements. And it has to be able to indicate if the requirement has passed or failed its test. The table on screen is an example of how a checklist might be represented. Checklists can be used in different ways on a project. For example, they can be used to verify and ensure that project deliverables meet customer requirements, that all project supplies are acceptable for the project's needs, that each step of a process has been followed, or that everything is ready for the big event or milestone. Checklists are very flexible and useful tools for a number of applications on a project, including determining if a project has met its requirement and is therefore successful. You might be thinking that as project manager, you will be responsible for quality control on a project. This is often not the case. Usually it is not the project manager's job to determine if the project was successful or not. This job is usually done by the quality manager, who conducts an independent evaluation of the project's outputs. It is the project manager's job to produce the project on time and on budget. It is the quality manager's job to determine if the outcome is acceptable or not. Therefore, it is important for the project manager to know exactly how the quality manager will determine success on the project, and that clear success criteria exist. A project's acceptance criteria needs to be based directly on fulfilling or achieving the project's requirements. Since the project's success criteria is based on fulfilling the project's requirements, it is very important that the project requirements are clear and measurable, so that they can be independently tested. The formal success criteria of a project should never be based on people's opinions. Since they are so important to quality control, let's look at what good and bad requirements mean. Keep in mind that a project requirement specifies conditions or criteria that needs to be present for a project to be considered fulfilled. Let's start by first looking at what bad project requirements are. A bad requirement is one that is open to interpretation, in that it uses subjective language that can be interpreted differently by different people. Or it is one that tries to force a particular solution onto the project, instead of simply identifying a need or capability gap that has to be met. It is one that applies unneeded constraints onto a project by specifying restrictions instead of focusing on what needs to be done. Or it is untraceable, in that it is not linked to the project's purpose, objective, or deliverables, and thus it attempts to expand the scope of the project. A good project requirement is one that is verifiable, understandable, feasible, obtainable, and necessary for the project. With experience, you will come to recognize good and bad requirements. But a good starting point is, if you don't know how you're going to test a particular requirement, or if the requirement simply cannot be tested, then it's not a good requirement. Don't accept it. Always spend the time to clarify the requirements before proceeding with the project. You will be thankful that you did when it comes time to do quality control for the project. One last topic. There are clearly benefits to a quality management system in that it reduces the amount of rework required on a project, clarifies what needs to be done, how it needs to be done, and increases productivity while lowering overall project costs. It can also increase the chance that a project stakeholder will be satisfied with a project's end result. However, some organizations worry about the cost of a strong quality management system. When considering the cost of quality for an organization, you need to consider both the cost associated with implementing and maintaining a good quality management system, as well as the cost savings that will be encountered by having such a system in place. Most organizations find that fixing defective products are a lot more expensive than building them right the first time. The same findings apply to projects. Fixing defective products after they are built is one of the most expensive ways to produce products. Consider this as you put together your quality management system for your project. That was our short walkthrough of quality management. At this point, I encourage you to carry on your studies of quality by reviewing the PMBOK Guides chapter on quality and the quality-related material found in the course textbook. I hope that this brief introduction has given you a strong start to your studies in project quality management. I hope that you found this video useful, and in closing, if you're one of my students, I look forward to seeing how you develop your quality management assignments and in giving you as much practical and useful feedback on your assignments that I can.